Okay, in this video, we're going to start working on related rates. I'm going to have quite a few videos on related rates. So they're going to be as long, but there'll be plenty of them for the different strategies for related rates and the different types of problems. So first off, with related rates, you can see here's like a list of steps of things to do for related rates. It does seem like a lot, but like for instance, the first three steps are just stating your givens essentially. So when we get a problem, and there are three types. So here are the three types. First one is usually going to be some type of 3D geometry. And that's going to usually involve volume. Sometimes it will be surface area, but it's 3D geometry. The next one is some type of triangle problem. So it could be like two vehicles moving in a direction, different directions. It could be like a ladder. Those are typical. And then the third one, you'll see this more or so in BC, but it's going to be angle problems. So this is also going to involve a triangle, but they're going to involve angles. So those are the trickier ones of them all because people don't like trig, and trig is going to start popping out from there. And if you did do an older video in the archives, we did a problem that is very similar to or related to rates with an angle problem. We first started doing derivative with trigs functions. Okay, so here are the steps. Essentially, you're going to draw a picture, state what you're given, state what you're going to find out, figure out whatever the equation is. So those are the first four steps. That all can get done pretty quickly, and then all you're going to do is find the derivative and then plug stuff in to find the answer. It's not that bad, I promise. For some reason, this can get a little scary for some students, so kind of walk you through this here. So just one problem on this video, and that's it for 3D geometry, because they're all going to be the same with just different functions. So that's the only difference here between this problem dealing with volume and other problems with volume. It's just different functions. So it is good to know what some of the geometry formulas are of finding volume. So there you go. Water tank in the shape of an inverted circular cone with a base radius 2 and a height of 4. If the water is being pumped into a tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. So the first thing we're going to do here is we're just going to draw a picture. So we have some type of inverted cone. So this is what an inverted cone looks like. All right, so I do know that the radius here is 2, and this height here is 4. What am I given here? So I stated that, so I have radius 2, height of 4, and then the water is being pumped into the tank, and this is a rate. So this is a rate, this is a derivative. So this is going to be a dV dt. Because look at it's cubed, so it's got to be a volume. So it's being pumped in, so dV dt is equal to 2. All right, so I have R, I have H. Put an R equals, and then H equals, just so we have it. And we need to find the rate at which the water level is rising. So rising is going to be an H. So I need dH dt equals what? And this is at H equals 3. And this is all my givens. I just did steps 1 through 3. Drew a picture, stated my givens, and what I'm trying to find. I am trying to find dH dt. So the next step is just to figure out what equation are we using, and then we're going to go from there. And it gets a little bit on the heavier thinking side. So what equation are we using? Well, we have a cone. So let's go ahead and find the volume of a cone formula, which is going to be V equals 1/3 pi R squared H. Okay? So you need to know some of these formulas, okay, for volume. So cone is pretty typical, sphere is pretty typical, cylinder is pretty typical, a box is pretty typical, and those are really the only shapes that you need to know. If you don't know those formulas, you can always hit up the Google and it will help you out. So with this, I want to take the derivative, but let's look at what we really need. I need dH dt when the H is 3. So this is the cone right here. So I'm getting water pumped into a tank. I'll do blue for water if I can find it. Here's a blue. So this cone isn't full. That height is 3, okay? So I'm not using this H is 4 and this R is 2. That's going to actually help me replace this R because I want everything in terms of H's. Because I have a dVdt, so V is cool. We're cool with that. But I need dHdt in H's. So if I take the derivative here and I'm going to get left with an R and a drdt, I don't know that information. That does not help me. So I want to get rid of the R. So to get rid of the R is really using this proportion right here. So if I were to draw like a side view of this cone, I would get this right here. So I get H and this is R, correct? So this H is 4 and this R is 2. So this actually makes a nice little proportion. Because when I cut this, right here for instance, using brown, I have my H and I have my R. So every single cone is proportional so that the H over R is equal to whatever we're given. So in this case, our H over R is going to be 4 over 2. Okay, every single cone is proportional. So H over R is equal to 4 over 2. Now what I want to do is I want to get rid of R. So in order to do that, I need to solve for R. So when I cross multiply, I'm going to get 2H equals 4R. You divide the 4 over to get R by itself. You're going to get 1/2 H is equal to R. So that's really the tricky part. I have not done calculus yet. No calculus has been done, but I do know that I need this 1/2 H to go into here. With related rates problems, the calculus is usually the easy step. So this is usually the more difficult one, is figuring out, okay, getting my formula here down to just 2 variables, the V and then the H. So let's get rid of the R here. So I'm going to get brown. V equals 1/3 pi, I'm going to say that's H over 2 squared times H. All right. So now what I'm going to do is I'm going to make this formula look nice and easy. That's really my next thing. Make it a nice and easy formula so that I can take the derivative of it, and that part will be nice and easy. So V equals 1/3 pi H squared over 4 times H. So all I did was distribute the squared. And now I'm going to combine these constants right here. So I'm going to get 1/3. So the 3 and the 4 on the bottom, we're going to multiply. So V equals something over 12. Well, I'm going to have that pi out in front on top like that. And this is going to be H cubed. So again, I'm keeping everything nice and easy here because this derivative is pretty good. All right, so let's go ahead and take the derivative now. We're down to just our 2 variables. They're each on different sides. And this is always going to be with respect to t because it's always time. So we're going to do dv dt equals, we're going to get pi over 12 times the derivative of H cubed is going to be 3H squared, tag it dH dt. Okay, now we're going to use that information in our information up here and just start plugging in. You can make this look nicer. You don't have to. I'm ready to start plugging this stuff in. So dv dt is equal to 2. So 2 equals pi over 12 times 3 times h, which is 3 squared dH dt, because I want to solve for dH dt. When I do this, I'm going to get 2 equals, I'm going to simplify this a little bit, so that's going to make that into a 4. So pi over 4 times 9 dH dt. So 2 equals 9 pi over 4 dH dt. So all I'm doing is making everything look nice and pretty, and I'm ready to divide. So to divide is the same thing as flip the second and multiply. So I'm going to do 4 over 9 pi on this side, 4 over 9 pi on this side. So they're going to cancel out, and I'm going to be left with on the right side dH dt And on this side, I'm going to get just 8/9 pi. Okay? And now I'm also going to want units here. So what are my units? This is a rate, so it's going to be changing per minute. And what is changing? It's the height, so it's meters per minute. And there you go. So that is our first related rates problem here in calculus. This one is probably a more difficult one because of this little part that you have to do right here. But this is related rates.